Hello, friends. Welcome to Code with Mickey. I am Mickey, and I would like to take you through the massive multiplayer online code which I created for a dice game. Uh, this is also available on a public repository. You can use this code. Uh, I have Visual Studio Code opened here, and I would like to take you through the different folders which I have and the kind of architecture I have used. So I'll take you through the folders now. Uh, there is helper folder in which there is db.js. Now this db.js initiates the MongoDB connection to the database and also registers the user model. Uh, I have middleware which contains error handler JS and the utilities like the common functions which I need for the utilities. I have model. This user.model.js is the user schema which I'm using for the game user state persistence. Um, I have public folder. This is the entire front end for the game. There's a Redis folder which has got communicator. This communicator has got um all the different all the different communications. This contains all the different communication with the socket IO mainly. So this is a ES6 class. I'm using Node version 12.18 for this build because I wanted to use the class architecture here, ES6. This is very comfortable. There's a create game class. Now this class has got the entire logic and the creation and destroying of a game. This also has the gameplay features because here the entire game is being run from the server. So and the client is thin so that it only sends the command to the server to generate that kind of output. In this application, I'm using Redis as a cache layer. There are routes, so I have user routes in this, wherein I have authenticate, register, and a leave game. And there is you can get by ID and get all users. I have services. Now this controller is connected to user service, wherein I have all the services of users which I need to execute whenever I am working with the real-time game engine. There is config.json. There is different keys like the connection string, the secret for MongoDB, and Redis host, Redis port. I'm not using Redis auth for now because this is just a sample project, but in real world we'll have to use that. This is the index.js. This is my entry point, and here everything works. I'll come to this and explain everything about it. So this is the prod version of index, wherein if we have multiple cores, so we can fork these clusters and deploy the processes onto different core, so that by default Node.js takes only one core, utilizes only one core, and then whenever it is busy for processing something, the next request is queued and it won't process. So if we have a multi-core CPU, we can utilize that. I'll just show you the difference what happens once if I run npm run dev. It is just running the dev right now, so you see all these things, but this is just running a node mon dev. Here I will crash this and stop the server and clear it, and now I will run prod to it and see. So if you see this, the server is running on all the cores separately and it is sharing the port. So this enhances our applications performance for scalability. Okay. um, there's a license, there is model.js. So model.js is a singleton class which I have created for sharing the instances of a couple of things like the socket IO. I could have done it in the middleware also, like I could have shared it in the middleware also, but I wanted to use it in separate classes. That's why I had to create a singleton instance. There's a games array which I'm using for all the games, and there is a Redis client setter getter. So this is widely used in my system. Package JSON. So I have body parser, Express, JSON Web Token, Mongoose, Redis, Short ID, Socket IO, and Socket IO Redis. So all these dependencies are required to run this. Also, I have NodeMon for the dev dependency to run on dev. Now let me show you how this application works. I've started the application now, and I'll just see the database what I have. There are 5 users which I have used here created. So I will start my server here. This is one. I'll log it out right now. I'll start another instance of the game. Okay. So I log in using user 1 here on this window and user 2 on this window. Login. Now let me create a room in user 1. So there is a game lobby, room ID, and person is ready. All this is happening here also. Now game data is shown in the terminal as well. I'll do join to the second user and use this room ID to join to the second user. Once I do this, you can see at both places there are people. Now this person is an admin person, that's why it has got start game, and this person is a member person or user, so he has got only ready button here wherein he can say ready and not. If I log out and log in again, I will automatically come to my game lobby page. I can refresh and come to the game lobby page. I can ready or not ready here again. So I'm ready now, and let me start the game. Once I start the game, there is a timer running for 30 seconds for the dice to roll for the first member of the system. So I'll roll dice. As soon as I roll dice, my timer goes 0 and the chance goes to the other person. Timer starts here for 30. Now I cannot roll dice on the first user, but I can roll dice on the second user. As soon as I roll dice, I can see my current score and also the total score here. The total score here. Now the pointer again shifts to the first player here. There can be a number of players added to this, and the data is being saved on Redis. Now I will roll dice again. As you can see, the current score is 3 and the total score is 9. You see here, current score is 3, total score. So the this is getting updated at both places. I will try to finish the game as early as I can. So the entire data is coming from the server. Let's see. Now the highest value is 61. Whichever user gets 61 first will win the game. So I'll just roll dice again for the user. Let me see. 60, and for this one it is 47. So the first player is more likely to win the game, and I think they should be the winning turn because 61 is the highest score, which is the game end. So says you won the match, and say okay, and this guy said user one won the match, says okay, and now we can leave the game. Here also we can refresh, log out, and log out. So as we see here, there is some edge case when we leave the game after ending it because it doesn't get the key at the end. So they should actually throw you out directly to the uh, game screen, first screen. But I'll log in again and show you guys. So when I'll show you from the database side, I'll refresh it first. There is no change in the database here. What I'm doing is, as soon as I create a game and the player is in lobby, the database changes and it gives you the game ID here with the player. That player is in lobby and this is the unique ID of this player and the game ID is this. You can match the game ID here for the first player. Now whenever I refresh, it pulls the unique ID and game ID and connects the socket accordingly for the first player. Okay, and as soon as I leave the game, automatically the user is again free from any of the sockets here. So I create the game again and I have hosted again. Now I will join to the other guy's room. Joined. So let me show you this here. So these two players are in the same game ID in lobby and unique IDs are different. Perfect. So now I will start the game. As soon as I start the game, timer starts and the game starts. And when we see here, now they are in gameplay. So whenever I refresh, automatically my front end should give me that they are in gameplay. That is one thing. And when somebody leaves while playing, if I leave, then it says user 2 has left the game and the game ended. This is a force ending for both the players. So both the players have ended the game. And when I refresh this, now game is ended on the server as well as in the database. So none of the players are connected to any game now because they were in the same game and forcibly it is ended for both the players. Now I'll take you through the architecture and couple of things which I have created here. In index.js, I have used these variables for body parser, express, middleware, error handler. I've created the app and I've created a server and used that app on that server and I have connected that server to IO so that same port socket IO can work. For the application port, I've used 8080 and configuration JSON I have used because I wanted to give some common parameters wherein when we deploy, we could change the localhost address and things like that. Okay, so I've used communication class, I've used model as singleton, I've used game for the Redis game what we are creating right now. I'll explain this game class also. Uh, there is an array of games which is shared between all the classes so that we have all the game instances in this so that we can get the real-time values and utilize that game to process the connection to the players, okay, playing that game. I have Redis. I've used routes for user controller. There is a Redis client which I have created, and I've also used Redis adapter so that when we are running IO on multiple different machines, different ports, they can be clubbed together using this Redis host. Okay, so there's exception, and then I have initiated, taken the instance of model, and with the setter getters, I have shared the instances of games, Redis client, and IO to the singleton model for global access. I added some middlewares which are necessary for the routes and all, and I have added user routes and error handlers for errors being shown in the game. Now with there is a function called init server. Now this is the main function or entry point of my entire application. When we say when we enter here, we check Redis client for all the keys available. I've created this. If the server is restarted, we should not lose our games. We should not lose our games. So we check for all the keys, and with all the keys there, we create the sorry we create the games using the Redis client, and we set the data for init, and we push those games to the game model. Once we do that, what we need here is the game model games, so they can be utilized for getting the events from the game. Okay, and then I used communicator, and I've initialized the sockets. Okay, and then I have started the server. Now this is the entry point of my class. Now I'll take you guys to the communicator. These are the main pillars of the application communicator. So when we go to communicator, I've used model because I need some instances to be used. Short ID. Now short ID is used for creating the unique game ID, player ID, all these things. So I've used short ID. I've used user service to call a couple of services here, and the game because I need to create a new game with all these things. So I've used class communication, and I've created couple of variables here, and I have given instances of those variables from model. So I have init socket. Now here init socket, I have connected the IO for the connection, and I have used socket IO mainly to events which are being emitted from the client, like get player data, so I'm sending the player data, lobby updated, so I'm sending lobby updated. All these, this is the structure, like core of my game, wherein then when we get create game from the client, it creates a new game. So when it creates a new game, it takes a new game as instance and pushes it to the games array, which is basically the array in model. So it joins the now I'm using game ID as room ID, so it joins the socket for the room, and then we do get game data. Now this is get game data, which is being data is being pulled from Redis, is being emitted to the person who joins the room. So what I do is I create the game and then push that person to join the room. It can be admin or it can be not. So this, in this case, it is an admin. So I sent true for admin, and then the game stats are updated accordingly in the user services. Now user services game stat is the database entry which says I am in lobby. So this state is updated for the user. For users who join game, similarly, I will take the game data, I will put them to the room, and I will send them also the join room, but they are not admins. So they will automatically be added, and there also data will be added as lobby, and I'll update the game stats. Somebody who is coming again to the game lobby, we have rejoin game. Rejoin game, we have different criterias. We find the game of which game he was, because we get that from the database, and at which state he was, and then we can say he was in lobby, so we call that particular emit that particular communication from the client, so that there is a join room again, and join room says who is it and where it is added. Okay, similarly for the gameplay, we join the person here, we don't create the game. And in the start game, we start the game with the required data and emit for all the users in the global room, saying that the game has started. Then roll dice. So roll dice, in roll dice, the game is in the game instance, the turn is played. So turn is played. I'll take you through the game class also. So as I said, every data is being communicated from the server. So when the data is communicated from the server, we are going to see that everything is there. Everything is being handled from the server. Okay, so um socket IO disconnect, you get the user disconnection information. So I'm not utilizing it for now, but yeah. Find and get game is the function which finds the game instance, and the user can communicate to it. I will open the create game JS. Now this is the game JS. This is the core gameplay of my system. Class game, and there are particular variables which I need. Max time we can change here for the countdown timer, and win score also we can change. Max players I was using earlier, but now I'm not using it because I wanted to open it for maximum people who are playing. Uh, so in the constructor I'm using Redis here, but I'm not actually taking Redis from outside. I'm using from model only now because I changed the architecture a little bit. So this can be removed, but I have not removed it yet. So this is for when we the server restarts and when we need to get data from Redis and create game instances for all the games being played, and people shouldn't lose their game. So that is for the server restart I've used. Add player is the when players are added to the game. This is called. Uh, uh, when the player data is updated, their state is updated, then this function is used. And this is the compute next turn. So whenever there is a turn change, this computes next turn, and set player turn will actually set the player turn and show these pointers which are seen in the front end, that whose turn it is. Start turn countdown. So every turn is started with a countdown, and if somebody clicks roll dice, play turn is executed, and once play turn is executed, the interval is cleared and play is executed. So the score is calculated for that person, and there is an emit to the game saying that the gameplay is updated for players. So the game player then we check for the result. If the score is more than or equal to the win score, then somebody won. Who won? That that is emitted to the room. The game is stopped, the Redis is cleared, and the services is also accepted for the game, and the data for the current player is sent to the client. So this is how it happened. Now check win I earlier created, but I need to remove it. Uh, get room ID is one function. Create game is a function wherein you create the games. Remove player, add player. So there are a lot of methods which are being used to support this game class and support the gameplay core game engine. This is the entire game. The repository is available in the descriptions below. So I would like you guys to learn. Thank you so much.